Hello, welcome to lesson 4.2, talking about convex quadrilaterals, specifically parallelograms. This is our first quadrilateral that we're going to be introducing. We're going to be talking about all the different properties that are associated with a parallelogram. So first of all, the definition is a quadrilateral with both pairs of opposite sides parallel. We can mark these sides with arrows that show the two pairs of parallel sides. Okay, you see the sides opposite one another are parallel. Our first theorem that goes along with parallelograms: if a quadrilateral is a parallelogram, then consecutive angles are supplementary. Okay, consecutive angles are supplementary. Now, consecutive angles mean angles that are next to each other as we work around the parallelogram, clockwise or counterclockwise. Okay, so angle A and angle B are consecutive because they're right next to each other. All right, they're right next to each other as you go around the parallelogram. Now, if I wanted to, I could also say that angle B and angle C are consecutive. Okay. Now, the nice thing is I actually know this C, which we're going to get to in a little bit. C is going to be the same measure as A, but they're still supplementary, okay? Meaning that if I were to add A and B, because they're consecutive, if I were to add those two angle measures, they would add up to 180 degrees. If I were to add up angle B and angle C, they would add up to 180 degrees. Okay? And I could keep doing this all the way around. C and D are consecutive angles. If I add them together, I would get 180 degrees. And lastly, I could do angles D and A, which are also consecutive angles. Adding them together would give me 180 degrees. If a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. This goes back to what we showed on the last slide. Angle A is going to be congruent to angle C, and angle B is going to be congruent to angle D. And this is always true in any quadrilateral that can be classified as a parallelogram. Opposite angles are congruent. Another theorem: if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So these arrows that are written in our quadrilateral A, B, C, D here, these arrows mean that they're parallel. Opposite sides are parallel with one another. If we want to show that they're congruent, we need to use hash marks. So side AD is congruent to side BC, and side AB is congruent to side DC. Okay? But opposite sides will be congruent in all parallelograms. Okay? All parallelograms. That's why we can call it a theorem. All right, I think this is our last theorem. If a quadrilateral is a parallelogram, then diagonals bisect each other. Okay, diagonals bisect each other. And here's what we mean by that. The diagonals in this parallelogram go from A to C and from B to D. I'm going to redraw that one. I don't like how crooked it is. All right, let's see. B, there we go. Okay. Now, they bisect one another. Remember when we bisected a segment or bisected an angle, we cut the angle in half? Well, these diagonals are cutting each other in half. So I can take this diagonal AC, that's cutting the diagonal BD in half, giving us two congruent segments, okay? So if I were to say, let's make this point E here in the middle, well, the length between EB is going to be the same as the length ED. All right? Now, the same thing goes, BD is also bisecting segment AC, or diagonal AC, making EA and EC the same length. Now, all four segments aren't equal to each other, okay? But the diagonals do bisect each other. So we will get two segments congruent on one diagonal and two segments congruent on the other. here's that list. If you need to pause the video and write these down, here's the list of 4 theorems which are associated with all parallelograms. Okay. Well, using these theorems, we can actually solve for all these different variables that we have here. Okay, we've got x, y, z. There's a w on there. We can find all these. Let's see if we can find them all real quick. Write them up here. We got w, x, y, z. Let's see. W is located right here. Well, I know that the diagonals bisect each other, so this segment is congruent to this segment. So if EB is 6, then ED is also 6. So W is going to equal 6. All right, there's W. X. X is up here. Well, I know that sides across from one another are congruent. So this side and this side are congruent to one another. So if DC is 13, so is AB. So X is going to equal 13. Let's see, Y. Y is over here. You can use the same theorem. Opposite sides are congruent. So we know that AD is congruent to BC. And since BC has a length of 9, AB does as well, or AD does as well. So Y equals 9. And lastly, Z is right here. Well, we got the diagonals bisecting each other again. So if that segment is 7, EC is 7, so is EA. So Z is going to equal 7. Okay, and that covers all 4 variables from this diagram. Okay, used a couple different theorems. The opposite sides are congruent and that diagonals bisect each other. Okay. Here's one where we're going to use a couple different theorems as well. I know that opposite angles are congruent, so I can go ahead and I see D. Actually, let's write these over here. X, Y, and Z. Well, D and B will be congruent because they're opposite one another. So if D is 65, B is also 65, which is Y. So this will be 65 degrees. All right, let's see. I need to use the other property to get one of these to either get Z or X. Let's go ahead and figure out what X is. Now, what I'm going to use here is the fact that I've got consecutive angles. B and C are consecutive angles. I know they are supplementary. So if this angle here is 65 degrees, angle C will be 180 minus 65, which is 115. So X is going to be 115 degrees. Okay, because I know they have to add together to equal 180. Now I can find Z, which is the measure of angle A. I could find that a couple different ways. I could now use opposite angles are congruent. Okay, so angle C and angle A. So I could show that that is going to be 115 that way. Or I could use the consecutive angles being supplementary because now I know both of the consecutive angles that pair with A are 65. So I know Z is going to be 115. Okay, there's our three variables and their solutions for this exam. Find all angle measures for the parallelogram below. Okay. Now, in this case, we need to set up an equation because we don't know what any of the angle measures are right now. We just have a couple expressions. But what I know is that these angles are opposite one another, which makes them equal. So I can set up the equation 3x plus 18 equals 4x minus 9. I can go ahead and solve for x. I'm going to subtract 3x from both sides, leaving x on the right. Add 9 to both sides. 18 plus 9 is 27. So I get x equals 27. Okay. Again, this x equals 27 does not give you my answer because I need to figure out what all of the angles are, okay, what they all equal. But I can plug this in now to solve. So let's do, I don't think this is drawn to scale, by the way, but let's take this 4x minus 9 and plug in 27. 4 times 27 minus 9. Well, 4 times 27 is 108, and 108 minus 9 is 99. So this angle here would be 99. Actually, we'll do this. We'll do angle A, angle B, angle C, and angle D. Well, angle B we just figured out is 99. Let's do the opposite one. I know angle D is going to be 99. All right, A and C are going to be the supplement to B and D. So let's see, they have to add up to 180. Well, 180 minus 99 is 81. So these two angles would be 81 degrees. And as I stated earlier, not drawn to scale because this is actually B just drawn as an acute angle and it ends up being 99 degrees. So not drawn to scale, but for what we were given, these are the solutions. Okay? And you need to be careful that not everything is going to be drawn to scale. Sometimes you just use a standard looking parallelogram and you've got values and things that are plugged in there just so you can determine what the other values would be. Okay? It may not be drawn exactly to scale. Find all side lengths for the parallelogram below. Okay, so in this example, we have to solve two equations, okay? Because I know opposite sides are going to be congruent. Okay, opposite sides will be congruent. So let's see, let's do the one where we solve for x. So let's do 5x plus 2 equals 3x plus 12. I'm going to subtract 3x from both sides, subtract 2 from both sides, and then I get 2x equals 10. So I divide by 2. I get x equals 5. Well, to solve for one of these side lengths, I have to plug 5 in. Well, 5 times 5 is 25, plus 2 is 27. So AB, the length between AB is 27. I'm going to plug this in down here just to make sure I did it right. This is all a good way to check and make sure you did it correctly. 3 times 5 is 15. 15 plus 12 is also 27. So we've got those two lengths as 27.